Okay, welcome back. This is the second video of the series. Today we're going to be starting a new topic. This is going to be vectors. Okay, I know a lot of you are excited for this new topic, vectors. It's a new topic, okay, brand new. No one's ever seen it before like last year. Okay, last year was the first year. This is the second year there's vectors. So there's not a lot of content out there for vectors, okay, but that's fine. Plenty of practice out there for you to do in the textbooks, and there is like 1 year set of past papers for you to do. Okay, so we'll just start with the basics. Okay, all right. Okay, so vectors. So the very first question we're going to ask is, well, what is a vector? Okay, so what is a vector? Okay, so we can describe any vector with only two things. Okay, so we can describe it with a vector has one, a direction, and two, a magnitude. Okay, or length, which might make a bit more sense to most people. Okay, so let's draw an example of a vector. Okay, like that. Okay, well, vectors obviously have to be straight as well. So the direction has to stay the same. It's one direction. Okay, so remember, one direction, exactly one direction. One direction, except for zero. For zero vector, which is just a point, which we'll look at in a second. So the zero vector is just a point, okay? So it's like, has no length, okay? Zero vector has no length. But now, we're gonna just look at a standard vector, okay? So here. So look at this vector here, okay? And we're gonna see this vector clearly has what we described, okay? It has a direction, it's sort of going that way, and it has a length, okay? This is the length, okay? So this is the vector, okay? Well, this one is also a vector. That is also a vector, okay? It's a little bit wobbly, but let's imagine that they were all straight. Okay, so now our question is, I'm going to make an exact copy of this vector. Okay, so we're going to hit the copy button, hold down, and then we're going to paste. Okay, so here we go. Here's our exact copy of this vector. We'll put him over here. My question is this vector here and this vector here, are they the same vector? The answer is yes. Okay, it's the same vector because it has the same direction and the same magnitude or length. Okay, I've copied it exactly. Okay, so these two vectors are going to be equal to each other. Oh, I rubbed it out accidentally. These are going to be equal to each other. Okay, these are not equal to each other. They're pointing in different directions and they have slightly different lengths. Okay, all right, cool. Now that's all fine and everything. But now our question is, well, how do we actually name these vectors? Okay, I'm not going to call this one Bob. I'm going to call this one Jane. I'm going to call this one T-Marts. Okay, and this guy, he doesn't get a name. The last guy doesn't get a name. Okay, but unfortunately, these names, as cute as they might be, they don't tell us much about the vector. Okay, well, actually, these two are the same vector, so maybe we should give them the same name. So maybe that can be also Bob. And this one can be Jane. Okay. Well, unfortunately, as nice as these names are, they don't tell us much about it. Like just saying, okay, well, this is Bob. Well, what does Bob look like? Well, for someone who doesn't actually have a picture of what Bob looks like, no one knows. Okay, so it's not a very good name for Bob. Okay. So how do we actually identify a vector? Okay, so how do we identify a vector? Okay, so let's look at vectors in 2 dimensions. So you can have a vector in 3 dimensions too. Just imagine a line sort of just out hanging around in space. And we can also have vectors in 1 dimension as well, but they wouldn't be very interesting as you could only just go forwards and backwards and have different lengths, but you don't have 2 directions. Okay, so let's look on the very familiar Cartesian plane. Okay, so here's the Cartesian plane. Okay, with our y and our x-axis. Okay, and we're going to draw our vector on this plane. Okay, so let's draw it over here. Okay, so how do we describe this vector? Well, simple way we can describe it is just how far does it go to the right And how far does it go up? Okay, well, how far does it go to the right? Let's say it goes to the right by 4 units and it goes up by 3. Okay, that's cool. So now let's give this vector what we call a column vector. Okay, we'll call it a column vector. Write it in column notation. Okay, so we use square brackets here. Oops. And then on the top, we say how much does it go right by, which is 4, and how much does it go up by, which is 3. Okay, so this vector here is 4, 3. Okay. Now, it doesn't matter where on the plane we put it. So we can put it down here if we want. As long as the vector still goes 4 across and 3 up, okay, then this is still the same vector, 4, 3. Okay, these vectors are equal to one another. Okay, so these guys are equal to one another. Okay, so now that we know they're equal, well, how do we actually notate them? Okay, so we wouldn't want to write 4, 3 every time we use it. Okay, just like how in algebra, we can assign a variable name to something, right? We can say, well, let x equal 3, okay? And that would be good, okay? So example, in normal algebra, let x equal to 3, okay? And that's fine. But the problem is when we're using vectors, right, we don't want to use our normal notation because we don't want to get them mixed up, okay? For example, let's say we have a vector a, okay? Vector a equal to, and we'll call this one 4, 3, okay? But this a here, how do we know without looking? So let's say if I covered up, let's say we cover up our, what it's equal to, how do we know which one's a vector and which one's a normal number? Well, we don't, right? So we have to find a way to distinguish them, okay? And the way we do that is we put a little squiggly line under it, okay? Other notations that we might have seen is a bold writing, okay? Like a thick, bold color, okay? Generally, you'll see that on sort of typed notes, okay? Or typed textbooks, but we don't usually see it handwritten, okay? It looks a little bit strange. And another way we can write it as well is A with a little arrow on top to show that it's a vector, okay? But this is the most common way that I see people writing it, okay? So this is most common way. Okay. And yeah, the reason why is what if we had A and we wanted to put variables inside here, like X, Y, okay? Then we can see the X and the Y here are normal, so they don't have this underline under it, no underline. So it means X and Y represent normal numbers, and this A with a curly thing under it, that means that it's a vector, okay? So that's how we can make sure we don't get confused between the two, okay? Now, what can we do with vectors, okay? We will look at a very simple operation in vectors, okay? Which is going to be the only one that we do today, but there's a lot more you can do further on with vectors, but we're only going to put one in this video, okay? So how do we add vectors? Okay, so let's get our same vector A with components 4, 3, okay? Go 4 to the right and up by 3. And let's have a new vector B, which is, well, we can even have negative numbers in here, -1, -1. Okay, what does that mean? This means instead of going to the right, you go left by 1 and go down by 1. Okay, so what is A plus B? That's our question. What is A plus B? Okay, this simply means follow A, then follow B, in simple terms, okay? So how do we do that geometrically? Well, simple. We draw A first, so that means we want to go 4 to the right and then up by 3. And once we have done that, we will follow B. Okay, so this is A. And then we want to go left by 1 and down by 1. Okay, so maybe it's like this. Okay, B. Okay, and we'll do -1 and -1. So we end up here. Okay. Now, Well, then what was the vector a plus b? It is just the combination of the two. Okay, well, we could have just followed a plus b to begin with to get to exactly the same point. A plus b. Okay, so that's where a plus b takes us. It takes us to the same spot as we would by doing a first and then doing b. It's like a combination of the two. Okay, now how do we work this out algebraically? Okay, so a plus b sort of looks something like this. Let's move it out here. Okay, by sliding it across. Okay, so this is a plus b. How much does it go up by, and how much does it go to the right by? Okay, because we want to find out. Well, what we can do is simply add the components of a and b together. So a plus b is equal to 4, 3 plus minus 1, minus 1. And then we simply add the top parts together. So 4 plus negative 1 gives us 3. And then 3 plus negative 1 gives us 2. Okay, so we know that a plus b means we go to the right by 3. And then now we go up by 2. Okay, and that is how we add vectors. Okay, so that's all we're going to cover today for this very, very brief introduction on vectors. Okay, for more, we can hopefully wait to see if we do any more videos, or you can join us on a journey in learning the whole vectors unit. Okay, so thanks for watching the video, and I'll see you in the next one.